Good morning to all my dear students. In this video, today we are learning about pinacol-pinacolan rearrangement. It is the first rearrangement which involve electron deficient carbon atom. First of all, we will see pinacol-pinacolan rearrangement definition. It is an acid catalyzed rearrangement of vicinal diol to give corresponding carbonyl compound. In pinacol-pinacolan rearrangement, OL stand for alcohol, that is vicinal diol, and ONE indicate the pinacolone means ONE indicate carbonyl compound formation. Okay, so as we said, pinacol-pinacolan rearrangement, it is acid catalyzed, means we can use here acid. We can use any acid. Suppose we can take here a mineral acid or Lewis acid. Okay, it is an vicinal acid catalyzed dehydration of vicinal diol. So let's see its mechanism. Here I take diol, vicinal diol, which is treated with H plus any acid. Suppose we take here H2SO4. So H2SO4 gives H plus. So reaction start with the abstraction of proton. So here both OH are in a same environment. So suppose we take this oxygen lone pair, it abstract this proton. So we will get CH3, CH3, here OH, C, CH3, CH3, O, H, H, positive charge. Here oxygen will get positive charge. Let's say OH itself, it is not a good living group. But when we take positive charge, it became water molecule, and after getting positive charge on the oxygen atom, it will show minus inductive effect. So it tried to depart from that molecule. So here water molecule depart, and we will get CH3, CH3, OH, C, CH3, CH3, and after the departure of water molecule, we will get positive charge on the carbon atom. After the formation of this carbocation, one of these group present on this carbon will migrate from here to this carbon to get a more stable carbocation. So we will migrate CH3 group on this carbon. So we will get CH3, 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 here CH3, here OH, and here positive charge. This carbocation is more stable than this carbocation due to presence of empty p orbital and the oxygen lone pair, which is transferred in the empty p orbital of carbocation. Then the oxygen lone pair will back attack on this carbon. So we will get CH3, 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 C, CH3, double bond O, here H. After the transfer of oxygen lone pair between carbon and oxygen, we will get positive charge on the oxygen atom. In the reaction, we take acid plus as a catalyst. After the completion of reaction, the acid catalyst regenerate here minus of H plus like this. So we will get CH3, C double bond O, C, CH3, CH3, and CH3. This is our product, that is pinacolan. Okay. In next example, suppose we take example like this in presence of H plus catalyst. So here is the question, which OH will abstract the proton. Here there are two types of OH which has different environment. This OH
attached to the carbon having two benzene ring, while this carbon has one benzene ring and one CH3 group. After the first step is the abstraction of proton, then removal of water molecule. Here in both cases there is a departure of water molecule, but the question is which carbocation is more stable. If we remove the water molecule from this carbon, we will get positive charge over here. If we remove the water molecule from here, so we will get positive charge over here. So look, this carbocation is more stable due to the presence of two benzene ring. This carbocation is delocalized in two benzene ring. That's why this carbocation is more stable as compared to this carbocation. So first we take this lone pair, abstract this proton, and we will get this molecule. C, PH, PH, O, H, H, positive charge. After this, water molecule depart here, minus of H2O. Then we will get C, PH, PH, C, CH3, PH, OH, and then positive charge. We will get this molecule. After this, we have to migrate one of these group from that carbon atom. So we will migrate PH group. So how to determine which will group migrate? So migration aptitude will be, first of all we have to migrate H, then we have to migrate PH, and then migrate R. R may be any alkyl group, and this is practically observed. So we migrate here PH to this carbon. So we will get C, CH3, OH, C, PH, PH, and here PH. After the migration of this group to this carbon, we will get positive charge on this carbon atom. So we will show positive charge on this carbon. After this, what happened? The lone pair present on the oxygen, it transfers its electron in the empty p orbital of carbocation. So we will get C, double bond O, oxygen transfer its electron to the carbon. So oxygen will get positive charge. Here is the CH3, and here it is attached to carbon which contain 3 benzene ring. After this, we use acid as a catalyst, so which is degenerate in the last step, minus of H plus. So H plus will degenerate and we will get product CH3, C double bond O, C, PH, PH, and PH. And this is the product for this reaction. Likewise, we take another example. This molecule contain plane of symmetry. So both OH are present in the same environment. So we can protonate any of these. So I can protonate this OH. So we will get again water molecule over here. Here we will get O, H, H, positive charge, and here OH. Next step is departure of water molecule. So we will get minus of H2O. We will get positive charge over here and here OH as it is. Next, this is a different example where we don't have any group on the alpha carbon to the carbocation. So here we can migrate the beta bond to the carbocation. So we have to nomenclature as alpha to carbon containing OH group and beta to next to it. We have to migrate beta bond to the carbocation. So we will get alpha beta bond break and electron on the alpha beta bond will shifted on this carbon. So we will get positive charge on the carbon which is having OH group, means alpha carbon. So we will get, if we break this alpha beta bond, then there is a ring expansion phenomenon. So we will get 1, 2, 3, 4, 5, 6 member ring. So we have to draw first of all 6 member ring. 6 member ring which is attached to 5 member ring. Likewise, so we take first to this carbon, then second, then third, then fourth, then fifth, and then sixth. We know that on second carbon there is a OH. There is OH and the positive charge here. After this, the lone pair of oxygen shift in the MTP orbital of carbon. So we will get double bond in between carbon and oxygen. So we will get C double bond O and the 5-membered ring attached to it. This is the product for this reaction.
Thank you for watching.